All right, episode 4. We're going to talk about patch layout. Patch layout 101, the basics. So the inspiration for the models in this module came from a discussion on the Rhino forum with a user who's been working on doing some boat hulls, and he's was trying to demonstrate to a client that he could build a conceptual model sort of based on other boats similar, and I was just kind of intrigued by the way that he went about and did it. The result. It seems like he has some sort of a numerical generation, method of generating all of these cross sections. So these are the curves that he supplied. And if I grab any one of these curves and turn on the points, you can see they're very, very dense. The curvature on this stuff is halfway decent. Actually, it's pretty darn good. In fact, the curvature even on this result is frankly like way better than I thought it would be. But there's no free lunch with this. There's some downsides to this approach. And so what I can tell you about how this surface was actually generated was through some form of feeding all these curves into a function in CATIA. And I don't use CATIA, and I'm betting if you're listening to this, you probably don't use CATIA either. I don't feel like paying for CATIA. I couldn't afford it. And so I found this result interesting, but not very instructive. And I think there's a lot of interesting stuff that we can talk about in terms of patch layout on boat hulls, because they're a fairly simple case of modeling, but there's a lot that you can learn and then extend into making other things, right? So the other thing that's very interesting about this output, right? So the inputs, as you can see, it's very dense. Everything, like I said, is just tons and tons of points. And then the surface output, this is the surface output. And these aren't iso curves. These are edge curves here. So it's kind of interesting to me. There's a weird flow to all these edges where everything's got this kind of, this backward bent to it. So I thought that was kind of interesting. We're also going to talk about how do you actually solve the problems at the front of a boat, right? There's a lot of a lot of people kind of hide their dirty laundry on these boat hulls. And the dirty laundry right here is this surface right here. You can see what we've done is we've taken something that should be four-sided, or that is four-sided, and we've kind of pretended that it's a three-sided surface by kind of smashing two edges together like that, right? So, and then, the other thing to notice, this is 385 surfaces, right? So part of what's not great about this is that there's no way for us to directly edit this. I mean, we could scale it, right? We could scale it in certain directions. You could even, if you wanted to get crazy with it, like you could use things like cage edit, right? But this is just so dense that there's no way to edit it, which is the same thing, right? As these curves. We can't edit these curves. They're way, way, way too dense. Not directly, at least, right? And then the other thing is just from a surface modeling standpoint, like this is all well and good to pop out a hull with this, but when you start using things that have this many patches in production, right? Like, so let's say I throw a keel on this, and then I make a blend with my keel into here. Well, that blend, it's going to go over like so many surface edges, right? And all of those are going to make it more difficult. It's going to probably break up my blend into lots of bits, right? So, this is a a nice, pretty, fairly smooth. Let me turn off the edges and the isos. This is a nice, pretty, fairly smooth surface, but it really locks us in, and there's not a lot that we can do once it's baked in like this. All right, so that seems like it's kind of a tangent off of patch layout, but it's all gonna come back together, trust me. All right, one thing I wanted to add is that the purpose of this is to show the patch layout that we need to make a boat-like shape, right? We're not specifically going to be perfectly rebuilding this hull. That is a much more difficult task. But we first have to understand, like if the job was to rebuild this as a Class A surface model for production, because we wanted to solve all those problems of like there being too many patches, or having it be a little more editable, right? Having it be friendlier to blending in, so we don't have trims that have 100 edges to them, right? So solving that problem is like in the constraints of, say that the customer comes to you already with this hull. This is very similar to like wing shapes where the airfoil is locked in. That's a much more difficult task. So we're going to lay the foundation for how to do that in the future right now. So we're going to make a boat-like shape, but we're not going to make exactly this boat. All right. So I took that model, I took that geometry, and I totally rebuilt all of it. And this just goes back to what I did in the previous module, right? So these are all my new curves, and I turn on my points, right? Everything is single span, okay? Everything is degree 5 or less. And they all have, if we bring up our curvature graph, they'll have just really nice curvature, right? Let's start with these, right? This is exact, we've got this really nice, smooth increasing curvature here, and then we have right up into our bow, right? We can edit this, right? We can sit here and we can make this, reflex if we want, right? Boo! We can do all sorts of stuff with this. This is all very smoothly editable, okay? So that's all review, right? This is stuff that we covered in the previous module. So if that doesn't make sense to you, go back and watch that. Because what we're here for right now, we're here for patch layout, right? So patch layout, we saw that we achieved roughly the same shape with 385 surfaces. Well, we don't need 385 surfaces to make this type of shape, right? What we need, really, well, let's talk about it. Let's figure it out. So we just need 2. And the reason why we need 2 surfaces is because we have a break here on the bottom, right? So we have the gunwale, I looked that up, is one continuous line. Now, I talked about dirty laundry. Here's the dirty laundry right now. This is not how we're going to actually end up solving this problem. But what you can see is I wanted to make sure just for this part of it that we kept everything four-sided, that we don't collapse this into a singularity, because singularities are bad. NURBS are four-sided. We need to respect the fact that NURBS are four-sided surfaces. We need to work around that, and we're going to get into that too. But really, right, how many surfaces do we need to model this kind of shape? Well, we need 2, right? So I've just blocked these patches out. These are not final shaped, but they're just showing you my patch layout, where my edges would be, right? And we need 2 surfaces. Both of these surfaces are single span, right? They have the same point count along the edge here. So I can match these exactly, right? These are all degree 5 along this top edge. What that means is I can match it exactly to this gunwale, right? They're degree 5 on this bottom edge, where this is I think this bottom one is actually less than that. But this is definitely degree 5 here. Where are my, oh, right. So yeah, this is degree 5. This is degree, let's see what's going on with that. What is this here? Oh, that's the curve. Oh, hold on. No, this is degree 4. Haha. This is a degree 4 curve, and this is a degree 5 surface edge. So we know that we can match that surface edge to this curve, right? So all of our surfaces are single span, and they're all untrimmed right now. There's no trims, right? And they're all set up in such a way, they have the right degree so that we can match them to our input geometry, right? And then not only that, there's such low point count that, you know, if I want to, I can grab these points and I can move this surface around, right? So this is very editable, very smooth, right? If I turn on my curvature graph, even without final editing this stuff, these are nice, smooth surfaces, right? So this is what we want to start with. And this is, you know, we can make this with 2 surfaces, right? And I should mention that all of these surfaces are being generated with the surface from edge curves command. And this is one of the few commands that really readily makes clean, well laid out surfaces in Rhino. I'm going to do a whole video on that in the future. There's a lot of Rhino commands that will sort of make overly complex surfaces. And if you have clean input geometry, surface from edge curves will give you what you expect. So that's, if you're curious, that's how all of these are actually getting generated. And I highly, highly, highly recommend using surface from edge curves. Okay, so on to the next. We're going to make this ever so slightly more complicated, right? Let's pretend like we now have a chine that we want here in the back, right? So there's going to be a break. What is our patch layout? Well, we still only need one patch up here, right? Nothing's changed here. But we should not ever, 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 because we have a hard edge here, we should not combine these two into one single surface, ever. They should just be 2 single span separate surfaces, right? So here's our patches for that. And of course, when this is done, we're gonna trim this back and we're gonna put a blend on here. Nobody actually wants, you know, 100% crisp edge here, but we need to start with it like this so that we can get this to that, right? So anytime I break up my, my guide curves here in my cross section, right? Anytime I break those up, it necessitates a break in the surface, right? It says like, okay, well now we need 2 surfaces to do that, not just one, right? Pretty basic, but again, this is one of those things where I just see over and over and over again. A lot of people, they'll just take all the curves from, for a hull and they'll just loft the entire thing through, right? In Rhino. And that's just not the way to do it, in my opinion, okay? So super simple here, right? So we've just created a break, and so it just means that we need one more surface in order to make this work for a patch layout. We go slightly more complicated than this. Let's say we decided instead of, here I'll just compare the last one. So the last one is this one. It smoothly goes in here, right? And let's say we said, actually what I really want is to kind of hold it in top view to just go straight back from there, right? Sort of tangent, straight back, and I want it wider here in the stern, okay? So we've of course had to create a separate curve here, okay? And so what this means for our patch layout, well, we have another feature, right? We have another break in our guide geometry. It means that this back here is now its own separate patch and should be and needs to be, right? So these two should not be combined because they have separate guide curves, right? So like along our gunwale now, we have 2 guide curves, right? Yeah, so we're going from like 2 surfaces to 3 surfaces to 4 surfaces. These are all like really basic, but again, these are things that I see just not understood over and over and over again, right? And these are, of course, this is the most basic of patch layout, right? There's no trims involved yet, right? Everything is 4-sided. We haven't had to solve any sort of sticky problems. But again, like we want to make sure that we understand these basics. And kind of like extending off of that idea, like why do we, like, you might be asking yourself, like, why do I even care about this stuff, right? I can make decent models, right? we have all these tricks. We've got multi-blend tools. There's all sorts of fancy patches and all that, right? I'm going to show you in this series how to solve 95% of the problems in your model. That other 5%, sometimes you do have to lean on, multi-blend tools. There's, the Xnerbs plugin, right? So the thing is if you create dirty surfaces that have wobbles in them, and then you get to where you need to use that tool is going to fail, right? So it's about, I don't reject those tools. I think those tools are sometimes necessary. If you got a 5-sided hole and you got 10 minutes to finish your project, well, yeah. But you gotta build all your primary surfaces such that when you do have to go rely on those tools are there for you. They'll work. They do the expected result, right? And so that's what all this is about, really. It's about making your life easier. Honestly, I find it's much faster to model once you understand these things. And then when you in a blue moon need to rely on these fancy tools, they work better, all right? So the next module, we're going to talk about trims and how do we solve 3-sided problems, right? Because basically this bow here, like I said, this is the dirty laundry, right? The bow is more or less a 3-sided problem. How are we going to solve that, right? But it's all going to build off of these basics. And I'm going to show you that we can make a very, very smooth, very editable, very nice hull with 2 surfaces. All right, so hope to see you in episode 5.